Hi and welcome to a Postbag, or should I say Postbox special. Now, I haven't actually opened this. The fact that it's slightly open is because I just started recording the beginning of the video and didn't have the microphone turned on. Professional YouTuber, of course. So anyway, we will carry on in opening this with audio this time round. So this came from China via eBay, and quite excited about this. So let's see what we got in the box. We got one package and some bubble wrap and something else in there which should give it away. Mind you, the title's already given it away. So what do we have? We have some laser safety goggles. Let's pop these out and see what they're actually like. These are just cheap, but I presume they should work about right. Let's have a look. Yeah, they look a bit cheapy, but stick them on. Yeah, okay. Kind of makes everything look a bit weird. So we got ourselves some laser goggles. So that means we've got a laser. So let's have a look. Right, we've got a sealed package here. Oh, that didn't work, did it? Time for a new blade, I think. So let's see what we've got in here then. Okay, so we've got the laser itself and we've got ourselves a PCB in a little sort of plasticky case there. I presume you could screw that onto something, and we will get into what this is going to be used for in a moment. So, well, they haven't done that very well, have they? Hopefully you can see that the writing's a bit rubbed off on that label, but never mind. Danger laser, yes, we know that. So wavelength 450 nanometers, power 2.5 watts, input voltage 12 volts. So we got focusable adjustable ring there. This is all made out of aluminium. Quite a bit of weight to it. We've got a nice little fan on the back there as well for cooling. So the idea of this is to mount onto the 3D printer. Now you may know I've got two 3D printers. The Ender 3, Gravity Ender 3 is the one currently being used to print the face shields. Still doing that, guys. The fundraiser is still up and running if you wish to help support that. So that printer is being used for that, and I've got the old printer which I did a video on, and that is the sort of ANET A8 clone, Chinese clone printer. That one doesn't get used, and so the idea was to convert it into a laser engraver. I don't think we'll be able to cut much with this, but maybe some very thin sort of balsa wood might be able to cut through it with enough passes. But yeah, so the idea is to convert that printer into a laser engraver. So let's zoom down and have a look at the board. Now, before we go into further detail on this PCB, just a quick message from my sponsor, PCBWay. PCBWay offer a high quality manufacturing service from standard prototype boards to flex rigid PCBs and even assembly. Why not take advantage of their $5 welcome voucher and get your first prototype boards free? Already have an open source PCB design? Join their shared projects area where you can list your design for sale, and PCBWay will donate 10% of the PCB cost to you as a way of saying thank you for your contribution to the open source community. Links are in the description below. Okay, so looking at this PCB, we've got this. I would assume is going to be our DC in. Yep, sorry, off screen. So that's our DC supply in, 12 volts. We've got a blue connector there that doesn't seem to be going to anything and doesn't appear to be marked with anything, so I'm not quite sure what that's for. Then we've got our two wires here going out for the laser. So we've got the blue and grey are the laser supply, and the red and black are the fan. And then we've got a small little switch here which goes between analog and TTL. So I need to look up onto that to see. I'm guessing the analog would be PWM. Yeah, PWM up to 12 volts, I presume, on analog, and we can... Ah, yeah, so that makes sense now. So that blue connector will be for driving it with the signal. And yeah, if we put it on TTL, then that's going to be up to 5 volts. So I reckon on TTL, this could be driven off an Arduino board reasonably easily. And yeah, that's the plan, to see if we can get this to fire up now, and then in future videos we'll be doing the build on the 3D printer. So how much did this cost? Well, I paid £45.99. Currently the listing on eBay has it down at £53.99, so they have put the price up a bit. Interesting, it's the updated listing. On the other one it did actually have some information, I think this one has got it on one of the pictures, as to how to wire it up. One thing that's slightly disappointing is they don't actually give you a connector to plug into here to supply the power to it. So yeah, I don't quite know why they've missed that one out. That does seem a bit stingy, because now I've got to try and find a connector that will fit into there, which I probably haven't got, but I'm sure we can bodge something and get this running. So let me go and get some bits ready and we'll see if we can get this to fire up. Okay, so I've printed out that picture which just explains things a bit more. So it's not printed brilliantly, but anyway, so we got the switch like we said between TTL and analog. Now TTL is going to run at 5 volts. It's going to be basically either 5 volts laser on, 0 volts laser off. So we want PWM control, so we'll do that as analog. And we've got on the blue connector, we have got the one to the left is the negative and the one to the right is the positive. Now I'm not too sure if the analog signal needs to be sort of 0 to 12 volts, or whether or not it will work on sort of 0 to 5 volts that the Arduino is going to kick out. Now when it's on the actual 3D printer, this will be controlled, yeah, probably either using like the heater control or something running at 12 volts. So I'm guessing it's going to be 12 volts. So I don't know whether or not we can get this to fire up on the Arduino, but we will give it a go nonetheless. So how are we going to connect this up? So I think what we'd do is, this is going to be our power coming in. We've got the negative is on the left side and the positive is on the right. So negative is white. So what we will do is grab ourselves a couple DuPont connectors. So we'll pop that in black for negative and orange for positive. So that's going to be 12 volt supply into the laser. So we'll just get that connected up to the power supply and try not to short anything out. So that's connected to the power supply, so let's pop that on and we will set that for 12 volts. Don't know what the current draw is going to be. Let's just give it 1 amp I think for now, and we'll just see what happens. So we turn that on. Okay, so that's running and we can see, oh, I'll tell you what, that's interesting. So that has actually fired up the laser just with the 12 volt supply. So let's turn that off before we get blinded and burn a mark on the bench there. Okay, so I wasn't expecting that to fire up. Let's switch it to analog mode and I'll keep my eyes away and just check if that fires up again. No, it doesn't. Okay, I see what's going on there then. So when it's on the TTL mode, it must be pulling its signal high, so it's naturally on as opposed to naturally off. So now we're on analog mode, we can see that the laser module is not powered, but the fan is running, and I've already burnt the bench mat there once already. Okay, so the next job will be to connect up the Arduino. So I'm going to turn that supply off again, just in case something bad happens. At least we know the laser module actually works. Just not how we wanted it to. So as they don't provide us with a connector, I should just be able to get these DuPont wires to plug in here. They're not ideal. I will have to try and source some kind of connector for that. The yellow one's not holding in very well. Okay, so that's in. So we've got then the negative is the left hand side again, so that's going to be our yellow wire. So we'll put that onto ground on the Arduino, and we're just going to stick the blue wire. Let's just put it on, where should we put it? Let's put it on pin 3 because that's a PWM pin. Okay, so that's connected up. So we're going to need some kind of sketch for this. So we get the Arduino up on the laptop. So it shouldn't need to do too much on this. So I'm just going to put in some basic sketch information. We're a define pin. That should be pin mode, shouldn't it? Pin mode 3 output. It's been so long since I've even used an Arduino, for ages. So pin mode 3 output, that should probably be enough we need there. So we're going to want, yeah, you can tell I'm rusty on Arduino, definitely. Right, so what we want to do, so pin mode 3 output, so we want to define, we want to give that pin a name, don't we? So let me just get that set up, and we'll pop back when it's typed up and hopefully ready to go. Okay, so I've only chucked a very quick sketch together. So I've got an integer for laser, it's pin 3, pin mode laser output, and we just got analog write laser at 255 for the PWM signal. Hold that for 2 seconds, then analog write to 0, so we should turn it back off again for 2 seconds. So here goes nothing, so we're going to see if this works. Now I don't really want to burn the bench mat anymore, so let's fold up this bit of paper. Now whether this works or not I don't know, because we are dealing with 5 volts as opposed to 12 volts, but we shall see. So I'm going to pop some goggles over me glasses, and we will turn on the power supply. Okay, power is on, and let's upload this sketch and see if anything happens. Sketch is uploading. Oh yeah, we can see the lasers turned on there, off, on, off. Okay, so we haven't got a very strong signal, strong laser beams, so can we focus that down? I think it does need the 12 volts. We seem to get very much more of a line, hopefully you can see that, as opposed to a actual small dot. So might be able to do something more with the focusing. So let's change that sketch to, actually we can do that with TTL, can't we? So we switch it to TTL, so the laser should stay on all the time. No, it doesn't. So let's see if I can focus this laser down or not. We know when it's focused when the paper catches fire. Like so. Yeah, that's pretty focused. So we can see there, yes, we can get that focused in pretty well. Let's get the Arduino connected again. So we got that focused in quite well, and that is now setting fire to paper. So the question is, if I drop this signal down to 100, will that drop the intensity down of the laser? Let's try that. So let's upload that sketch. Hopefully that should, yeah, let's drop the power down, isn't it, to 100. So that seems to be working fine with the 5 volts supply on the analog. Now does that mean we can give it 12 volts in the 3D printer? That's something I'm not too sure about. But these modules do get used all the time, so I'll have to do a bit of research. I'm pretty sure we can. So yeah, if you put the power down at, yeah, sort of, I mean that's less than half power, isn't it? That doesn't want to burn anything at all. So yeah, it does need to be as high as 255. So full intensity, and that should burn the paper, which it does. In stages, because I got it pulsing. So yes, that does seem to work. How well that's going to engrave, I don't know. I haven't got anything here at the minute to try it on, but we know we can burn paper, so that's a good start. So let's turn this off before I end up making a mess of the place. Okay, so power off to the laser. Good. I'm going to pop my goggles off. So yes, the laser does work, and yes, we can get it to fire up with an Arduino. And now the flat stinks of burnt paper. Never mind. There will be more videos following this, of course, when I get started with getting this mounted onto the 3D printer. There's going to be various things to go through with that, including number one, trying to get the board that's on it to accept new firmware so we can run this. I've been experimenting with that because I was actually trying to get it back up and running as a 3D printer since it's not been used for ages and it doesn't want to play ball, and I cannot get anything to upload to it. It runs off an Arduino Mega, but yeah, it's a Chinese board. I managed to sort of follow various instructions onto how to get it to actually upload to the board, and nope, it's point blank refuses to accept any uploads. So I've got to play around with that, see if I can get the board to upload something to it. Then at least we can get moving on this, and I will need to 3D print a bracket to mount this to the printer. So in future videos, guys, this will be run as a series. There'll probably be different videos in between. I don't know how long this is going to take to get done, but there will be a series running on getting this mounted on the printer, and then hopefully starting to engrave some things and maybe cut some things. So once again, if you like the video, guys, please do give it a big thumbs up. If you would like to help support me on Patreon, links are in the description below. And make sure you're subscribed for new videos, and I will see you soon for the next one. Thank you.